In this video, we're going to complete our derivation of the Sure estimator, which we began in the last video. So in the last video, we applied a transformation matrix P to both sides of our system. And we actually derived the exact form of the transformation P. We found that it was equal to the variance-covariance matrix of the system, which I've called sigma, or capital sigma, all to the power minus a half. And I spoke about how this is exactly the same form as GLS because essentially a Sure estimator is a type of GLS estimator. And we also rewrote the system in terms of rather simpler coordinates, and this is going to be useful in this particular video. So essentially what a Sure estimator is it's just doing OLS on the transform system. So if we calculate the OLS estimator on this transform system, that's actually going to yield us the Sure estimator. Okay, so what is the OLS estimator on the transform system? Well, beta hat, and I'm going to call this beta hat Sure, is equal to, well, it's the matrix of independent variables transposed, so that's omega primed times omega, all to the power minus 1, times omega primed times the dependent variable z. Remember, it's just x primed x to the power minus 1 times x primed y is the formula which we always have to remember. But because we have actually created these variables artificially, we can now go ahead and substitute back for what these things are in terms of p, x and y. So omega primed is going to be equal to x primed times p primed, because when you take the transpose of a product, the order of multiplication reverses. So it's that times omega, well, omega is just p times x, and it's that all inverted, times omega primed, which is just going to be x primed times p primed times z, and z is just equal to p times y. And we know that p is equal to p primed, and it's equal to capital sigma to the power minus a half. So when I multiply p by p primed, I just get a sigma to the power minus 1. So what we get out in the end is that our beta hat Sure, our vector of estimated parameter values, is equal to x primed capital sigma to the power minus 1 times x, all to the power minus 1, times x primed capital sigma inverted times y. So that's the form of the Sure estimator. And unsurprisingly, it is exactly the same form as a typical GLS estimator. The only thing that's different here in sort of concept is the fact that we're not just dealing with the variance-covariance matrix for a particular individual, let's say. We're dealing with one for a system of individuals, and I use the word individual not necessarily to mean an individual person. It could be countries, it could be states, it could be many different things. But yes, this is the Sure estimator, and this Sure estimator, because the transformed error satisfies the Gauss-Markov conditions, this particular estimator will be blue.